Hey everybody, this is Miss Eisencraft with Unit 3, Lesson 1 practice problems from our new geometry book. Starting on page 10, we're going to do numbers 1 through 3 and 7, all about scale drawings and dilations. So, polygon Q, this green one, is a scaled copy of polygon P. The value of x is 6, so what would the value of y be? Well, let me put 6 there. They've already told us 4 is scaled down to 3. So 6 needs to be scaled down in the same way to y. So I'm going to set up a cross product. I'm going to go 4 is to 3, or as 6 is to y. So what I just did there is I set up a ratio, and I said 4 is going to get scaled down to 3. Blue is to green, as 6 needs to be scaled down to y in the same way. So 4 is to 3 as 6 is to y. Now I can solve this missing value of the ratio by doing cross products. I know 18 to 6 times 3 has to equal 4 times y. Okay, so I'm going to divide by 4, do some simple algebra. It's not the nicest number, not a whole number, but it is 4.5. So I know y is equal to 4.5. That looks reasonable. Yep. Okay. Now for scale factor, we know that 4 got shrunk down to 3. So we know the scale factor is less than 1. So we can ask ourselves, so 4, you can ask yourselves, times what? Let's just put a big old X there for what? Times what makes 3? That's one way to solve it. What did we have to multiply 4 by to get to 3? Well, if you just solve this old-fashioned for scale factor, you're going to get 3/4. Another great way to think about it, so the scale factor is 3/4, that's why it shrunk, is the scale factor is always a ratio of the um, image to the original. So take a pair of corresponding parts, like this top segment. These are corresponding parts, and do image to original. So if you do the image to the original, this is super helpful, I think, this little guy. That will give you your scale factor. And so if you put the image, which is Q, right, 3 to 4, and then simplify it, this is already simplified, this is your scale factor. And if you did 4.5 over 6, you would get the same ratio, which is 3/4 or 0.75. So that is the scale factor. You can also express the scale factor as a decimal. There you go. All right, number 2. F, the smaller guy, is a scaled copy of E. We know that AB is 6, CD is, this guy here is 3, XY is 4, and ZW is A. So what is true? So these are the proportions that are true. Let's see. 6 will relate to 3. Okay, that makes sense. 6 will relate to 3 the same way 4 will relate to A. That is a true statement. Okay, let's try the next one. Next one is saying 6 relates to 4, so they're taking the horizontal segments. 6 will relate to 4 the same way 3 relates to A. Okay, that also makes sense. Let's try another one. Now they're trying to tell me that 3 relates to 4. Okay, those are not corresponding parts. Okay, and they're different parts. 3 is to 4 as 6 is to A. Absolutely not. No, that does not make any sense. Okay, how about, let's try this guy. 6 is to 3 as A is to 4. Well, they went the wrong order. They went horizontal is to vertical as vertical is to horizontal line. No. Then they're asking, how about 6 is to 4? Okay, so horizontal is to horizontal. But then they started with the small guy and went as A is to 3. So they went big to little, little to big. Nope. Last one, 3 is to 4. So they're doing vertical is to the horizontal. As A is to 6 does not make any sense. So your correct answers are A and B. Let's keep checking. Okay, so cross products or setting up equivalent ratios. This is something we worked on, I think, as early as sixth grade. So when you have two ratios or two fractions set equal to each other, the first thing you should always do is see if there's a nice multiplier. And what I mean is there's something that you can multiply the denominator or the numerator like across by. So look here. You can multiply 5 by 3 to make 15. So if there's a nice multiplier, just do the same thing up top. And there, you're going to get your answer. So x equals 6. It's way easier than doing a bunch of extra math. Okay? So this x equals 6 right there. For the second one, not so friendly, because there's not a nice multiplier that makes 3 to 7. And remember, we're looking for a multiplier. So here you can use cross products then. We know that 3 times x needs to equal 7 times 4. 7 times 4 is 28. So we need to go 3 times what makes 28? It's not going to be a nice number, but that's okay. You can get the decimal form or the mixed fraction, mixed number. 3 goes into 28 9 times, because 9 times 3 is 27, and 1/3. All right, use the calculator to get 9.333. Okay, let's do this one. 7 over 5 equals 28 over x. I'm going to do that thing where I first look for a multiplier, and I'm going to see one. 7 times 4 makes 28, so I can, whoopsie. So I can go times 4 here as well. If I see a multiplier, right, that's going to work out nice. So x is 20. And last one, not so nice. 11 over 4 equals 5 over what? Not a nice multiplier, or even a number to divide by to get to 11, from 11 to 5. So we're going to do cross products. 5 times 4 has to equal 11 times x. A simple one-step equation. You could do division. It's going to give you like a repeating decimal, I believe. 20 elevenths is 1 and 9 elevenths. So x is 1 and 9 elevenths, or the decimal equivalent, which I'm not going to write. All right, let's go. Boop, boop. We love to cross stuff off. Boop. All right, blast from the past, a little review. In the figure shown, lines F and G are parallel. Boop, boop. Those little arrows mean they're parallel. Select all angles that are congruent to angle 1. All right, so here's angle 1. So is angle 1? Yeah, it's congruent to itself. Yes. Okay, congruent to itself. Okay, how about angle 2? No, it's an acute angle. It's right, it's supplementary. It's going to add up to 180, but no. How about angle 3? It's also going to add up to 180 with it, but it's not equal. It's acute. 4, yes, 4 is vertical to angle 1. Yes, so vertical angles are congruent. So vertical to angle 1. And 5, yay, 5 is corresponding to angle 1. So corresponding, and we know corresponding are congruent. Angle 6, no. Angle 7, no. And angle 8, well, angle 8 is not, it's vertical to 5, which is corresponding to 1. So we could say 5 corresponds to angle 1, and angle 5 is vertical to 8. So if you could say, well, 1 is corresponding to 5, and then 8 is vertical to 5, then we can say 1 and 8 are the same. Yay. So I have A, D, E, and H, and that makes sense. 1, 4, 5, and 8. All right, good times.